All right, hi, ladies and gentlemen. My name is Aaron, and I am the weekend modder. And today, I am going to step through with you a problem that's actually come up in my own household. So, I modded a Xbox 360 Corona 4 gig console for my son, and it was working real well for him for maybe a month or two. And just recently, he's complained that it's stopped booting reliably. So that he has to reboot it and start it, routinely again here. So this is the console that I'm referring to. It's an E series Corona 4 gigabyte motherboard, and I just want to show you real quick and see if you guys can pick up on the little slight humming sound that comes out of these. One way you can recognize a Corona E series is there's something that happens in the feedback loop to what's going on with the glitch chip that makes the fan actually kind of put off this like high-pitched ringing sound. And in some ways, it's kind of cool because you can hear it, and each time that it occurs intermittently, you kind of know that you're attempting a glitch cycle. But as you can see here, even after multiple seconds and stuff, this console hasn't booted. It's really kind of hit or miss. Like it either boots within 15-20 seconds immediately, or it just doesn't boot at all. So what we're going to do today is uninstall the RGH2 glitch chip, remove it entirely, which is what was teased out in the title, right? Like we're actually going to remove the glitch chip, and we expect this console to behave better as a result of that, right? So that's what we're going to do, and stick around if you find that interesting. All right, so here's that console, just with the shell removed and most of the screws and stuff taken out. And what you can see here is this is a pretty standard ACE V3 on a Corona 4 gig install. So what we're going to do is actually do the software work first. I'm going to try to get through doing this without actually needing to solder anything on here to read and write the NAND. Since this console is already glitched and will boot, although somewhat unreliably, my intention is going to be to create the RGH3 NAND and then use the simple NAND flasher software to rewrite that NAND onto this console, then remove the stuff and wire it up for RGH3, and then boot it up again. That should mean that we don't need to reprogram the NAND via soldering, right? We can read and write it via software since it's an already RGH console. All right, so in order to create an RGH3 image for this thing, you're going to need the existing or original NAND dump or an existing UPD flash dump in. So I keep good backups, and I have the original NAND files for this thing, but just in case some of you don't, or maybe you got it without a backup copy or whatever, you can absolutely dump the existing NAND. And so I fought with the console a little bit and got it to go ahead and boot. And so what I'm going to do here real quick is just plug a USB in, which has the software Simple NAND Flasher loaded on it. And so you just drag the default.xex for Simple NAND Flasher and the folder over onto it, and I'll throw a link in the video description. And then, as you can see, I'm just plugging it in here. So I don't have a great screen capture set up, so unfortunately you're just going to get a video of the screen here. But it's a really, really straightforward process. So using whatever file browser or software that's familiar to you, I'm going to use the file manager built into Freestyle-3. I'm going to go down to USB 0, and there you can see that's the serial number of this console, that 293 whatever number. And then you can see Simple NAND Flasher right underneath it, and there's that default.xex here. So when you launch that default.xex, you get a really nice, clean presentation. Gives you your CPU key. If you don't have that recorded somewhere, make sure you note that down. You will need it for JRunner to do this next part. And then right here, it just tells you exactly. Press X if you want to dump your NAND, because it detects that it's a 4 gig, and it just gives us that option. So if you did not have an original copy to work with, this is what you'd want to do. So I'm going to go ahead and hit X on the controller, and it's dumping the NAND via software off to the USB. And then we'll use either that original copy or this dumped copy, either one is fine, in JRunner in order to build our RGH3 image. There we go. So we successfully dumped the NAND. The file is on the USB as flashdump.bin. and it took 48 seconds, and press any key to exit. So press the any key. There's not literally an any key, that's a joke. Haha. So we reboot into Freestyle Dash, and just to show you the file, because it's still on the USB, if I do the same and go back up to the file manager, if I go to that USB 0 now, and I go into the simple NAND flash folder, look at that flash dump.bin. So that's the dump of the NAND that we just took. So now we're going to pull that file into JRunner on the PC and build an RGH3 image. We'll save that to the USB, and then we'll do this process where we write the NAND from the USB to the console. And then at that point, we'll have to convert the wiring to RGH3 wiring. All right, so here's the USB drive loaded back up on my PC. And you can see this is a folder that I created. That's the serial number folder backup that I got from when I originally modded this console. And then here's that simple NAND flasher folder we saw on the Xbox. And as you can see here, we've got that flashdump.bin file. It also writes a CPU key.txt file for you. So it seems like you don't necessarily have to note it down off the screen, which is super handy. And so with JRunner fired up, what we can do is in the load source category, we can either grab that backup that we just created, that dump. So I'm going to go to the simple NAND flasher, and there's that flashdump.bin file. And because I use this same computer and install, it goes ahead and pulls in my CPU key for me. However, you could need to copy and paste that out of the CPU key.txt file. So there's our flashdump.bin loaded as our source. And so at this point, we just need to tell it we want an RGH3 image. And the cool thing is the JRunner beta version, big props to Josh of Octol's Console Shop, does support RGH3 now. So if you hit this glitch 2, there's an RGH3 checkbox. And at that point, we've got all the ingredients that we need to tell it to create an XE build image. So that's what we're going to do. So you can see what it's done here is it's created a updflash.bin and output all that, and then it actually runs the conversion script to convert to RGH3, and then it ultimately outputs a folder or a updflash.bin file. And it goes ahead and loads that up in the load source. So if you're looking for the path, the location, it's telling me it put it in the desktop serial number folder, which totally makes sense, right? So here's my original NAND backup that I had copied back to my desktop. There's that original NAND dump 1, NAND dump 2. And actually by doing this, I overwrote the updflash.bin that would have been in there, that would have been an RGH2 image. Now this file, and we can see confirmed by the time date stamp here, this file is an RGH3 file. So what we want to do is write this file to the console. So I'm going to copy that file back into the Super NAND flasher on the USB, right? So I'm going to copy the UPD flash, paste it into the simple NAND flasher folder on the USB drive. The naming of this file is relevant. You can see in the README of the simple NAND flasher software that it expects the flashing, the writing, to be supplied with updflash.bin, and it dumps the files to flashdump.bin. Those are just kind of arbitrary names, really. They don't matter that much, but this software keys off of them. So you want to make sure the software you want to, or the image you want to write is updflash.bin. So now we've got everything on the USB that we need. We can go ahead and unplug that guy and go back to the console and make it write that NAND. So, all right, so I've got that USB that we just loaded the file to here. So I'm just going to get that guy plugged in and get you guys set up on the screen again. So we should get the little normal, new mounted drive refresh sort of thing, right? Yeah, detected storage change. And then, so we'll go File Manager. We're going to go to the USB. We're going to go into the simple NAND flasher. And so we're going to launch that default.xex, but we can see right here the updflash.bin that we expect to see. So we should get some options. Yeah, here we go. So press A if you want to flash your NAND. Press B if you want to safe flash your NAND, which is to take a copy and write the new one. And press X if you want to dump just the NAND. So we've already done the dump. we don't need to dump it again before we write it. So actually I'm going to go with option A here, is press A if you want to flash your NAND. So that's what I want to do here. So I'm going to press A and press start to flash your NAND. Press anything else to exit. So I got to confirm with the start button. And do not touch your controller, so I've set it down in front of me, and we're just going to let it do its job. Alright, that's it. It's going to try to reboot here. So what I am going to do is, while it powers off, just in case it actually tries to power back on, I'm just going to go ahead and cut the power here, I think. I don't really want to attempt to boot it, because I know it can't be successful right now. And it can't be successful because I've got an RGH3 image written to a console that's still wired up as RGH2. So that's the kind of last step here, is that I need to swap out this wiring for RGH3 style wiring. So that's going to involve removing the glitch chip and the little couple of wires that go into that. Alright, so for the first steps, I'm going to just remove the wiring and the RGH2 glitch chip so that it's out of our way. And I'm just going to start with the wires that are up here. So you might want to use a little bit of flux on here, especially if your joints look like cold solder or whatever. This stuff looks okay to me, so I'm just going at it with a hot iron. You don't want to accidentally damage your stuff here. Alright, I'm going to leave those wired to the glitch chip. This one that's glued down to the other side of the motherboard, I'm going to pull that one up. And then the post one, I'm only going to disconnect this end. And I'm actually going to use a little trick here. So if you take your iron and then you run it parallel along but not touching the wire there, you can usually hit both sides like that just a little bit. And I'm being careful not to touch the board as well, just to free it from the hot glue here, so that that wire is no longer down there. And another quick tip is isopropyl alcohol or rubbing alcohol will just completely eliminate the bonding power of hot glue. So you soak that in there for 5-10 seconds with a really soaked pad, and then you can get that right off. So the glitch chip, it really wouldn't hurt anything to just leave it here. If you're nervous about peeling it up, the double-sided adhesive that's on these, so I'm going to go ahead and just remove these wires real quick. The double-sided adhesive that's used to hold these down in a lot of cases can be pretty darn sticky. So I mean, if you want to save your glitch chip, you can. The thing that I would avoid doing would be to do too much prying where you're leveraging against the motherboard. And that's just because there's a lot of traces and stuff on this guy. So I'm actually kind of using this tweezers as like a bit of a fork, and I'm really gently, well, not that gently, I'm pretty firmly pulling up, but what I'm doing is just kind of constantly applying the pressure rather than like a jerking or real hard motion, because it does loosen the string, like it kind of gives away a little bit at a time, like peeling a sticker without leaving the residue. Yeah, it's very much kind of what it is. See, look, the residue has separated a pretty good bit from the glitch chip, but we got it out of there, right? And you just kind of want to inspect the area and make sure, you know, you didn't leave some big scratch or something like that, right? So we've got that thing saved off. We could do something else with it later or whatever. We've got our PLL wire here. We've got the RST wire to deal with. Might end up just trimming that guy off flush here and just ignoring it. So now the RGH3 wiring that really needs to happen is actually on the back side of the console. So we need to remove this out of the cage and flip this guy over. So you can see that we've got the RST wire with a bit more glue on the underside here. So I'm tempted to just ignore that thing entirely. So what you could do is I'm just going to get a pair of snips here. And I'm just going to cut this off where it's back in the glue, so there's kind of nothing going on there. And then really Aside from aesthetics and cleaning it up, functionally there is nothing wrong with this. This is going to work just fine if I leave this wire here connected to nothing and glued in as it is. Especially if your confidence in your soldering ability is not super high, certainly recommend this sort of thing. I'm just kind of lazy right this moment and don't want to deal with cleaning up the hot glue and stuff. Plus, this is for a personal sort of console, so I'm not worried about it going to a customer or something. So let's get the RGH3 wiring diagram here and take a look at that. So yeah, here we go. So this is in the RGH3 beta pack that you can get directly from 15.432. I've done an earlier Trinity video where I have a repack of that, but ultimately, this image is very good, so I'm not probably going to reproduce them or anything like that. You can see here, this is going to be your struggle point, or the point where the PLL is very daintily connected to a via, and could be challenging for novices for sure. And then the post, in this circumstance, I want to point out that what it's highlighting here is a standard post out that is not using a postfix adapter. And as we saw on this console, right, we've got a postfix adapter in place. So we're actually going to go from this postfix to the other end rather than starting from here. This is a standard post out, which we do not have on this motherboard, so we used a postfix. So we're going to go from the top side postfix adapter to this SMC post, and then we're going to go just as pictured from the PLL point to the SMC PLL. And now the way that I'm going to choose to do that is by using one of the RGH3 QSBs that I sell. These are just a handy little quick solder board that takes the place of some of the bits of wire, and I personally feel like they make the install a little bit easier. So this guy right here, right? So this little QSB is going to help us get in the right position for hitting the PLL point. I'm going to go ahead and remove the X clamps here. You might also find the X clamp removal tool useful in this scenario. And I had somebody comment in the last video that they were scratching their board. So take a moment here with this. You can see how deep the forks are and how deep that would allow me to go. So you can see how deep the forks would go, and you can see how shallow I can insert them, and then also how deeply I can insert them. And if you look at the green bit underneath here, right, if I have this thing fully inserted and I tilt it, there's a likelihood I'm going to scrape the motherboard here. So the advice that I've given here is that when you insert that, you want to go just far enough that you're still resting on the underside, the little lip of this guy, right? So you don't want to go all the way in. You want to back it out till it's just in far enough, right? So I'm not going much further than about that, right? I still have a lot of gap around my teeth, and it stays completely on the X clamp that way. So just makes it really quite easy and very low risk for your console if you use the tool that way. So let's get that QSB on here. This thing has is it helps you actually identify the correct location by just kind of acting as a pointer right over to it, right? So at this C5R, what does that say? R40, R30, something like that, whatever. That's the point that we're going to go to, and you can definitely reference that image in the RGH3 pack. So right near where my face is here, look at that. Look, I can point. The PLL point is going to go right there to that guy, right? And so that little bitty tiny via looks just like this one. The technique that I'm going to use is actually to use a very sharp pair of tweezers and kind of perform like a scraping motion over it. If you're interested in that, check out my previous RGH3 tutorial video, and then I'll link like a timestamped link in the video description to that section for how to prep this point and stuff. Alright, this is about the best shot that I'm going to get with the current equipment I got out. So you can see the little via here is right at the base of between the 3 and the 5. The silk screening, which is the process by which they print on that lettering, can definitely vary a little bit. So pay attention to the relationship to, this guy, the little capacitor there, I think, as one way of, kind of keeping tabs, making sure you're on the right location. So again, I'm kind of using a technique where I stick the tip of the screwdriver or the tweezers into the via, and then kind of perform a scraping motion outward. Alright, so I think I've made some sort of progress there. What I will do now is actually just use a fiberglass scratch pin in order to try to clean that area up a little bit and see if that gives me a little bit of a reveal of the via specifically that I'm going after. So we can see this guy here. So I think we've managed to flake off a little bit of that top coating, get that guy exposed. You don't want to go overboard with the scratch pin, especially because you don't want to expose, you don't want to expose any ground and accidentally solder to something you don't mean to. Alright, feeling pretty good about that now. So we'll see if I can't zoom in on that a little bit here. You can see, let's see if I can point again. No. Anyway, you can see right at the base between the 3 and the 5 that that little dot is quite a bit more goldish now, right? And so that's where we're going to solder that long arm of the QSB. So let's zoom back out to normal level here. Let's get the QSB in place. Alright. So do just a little run over there. A little brush off of that guy. Just an anchor. And then let me grab a tiny bit of Scotch tape. What I got here, just tear it in half. And so I'm going to lay that over. And we're going to do our final positioning. Okay. Pressing that guy down. Alright, I'm going to get some flux here. Just use the tweezers to get some applied there. And let's see if we can get this soldered. Alright, that actually looks pretty good. It's kind of not the order that I generally prefer, but alright, let's get that guy down. And then let me remove this tape so I don't end up melting it. Let's get this anchored down again. Okay, let me just touch this up. The solder's not quite doing what I want it to do, so flex is your friend. There we go. Alright, now back to the nudge test. No movement. Nice and steady. Alright, so that should be our RGH3 QSB. Now, looking on those, actually if you look on the back side of the resistor itself, we actually get a little message on here, and it's going to be hard to read on screen, but it says Trinity 3K ohm, Corona 1K ohm. So for a Corona, we need a 1K ohm resistor. So I have a whole reel of those, and we need to install that. Now if you were doing a DIY yourself and you had a 1K ohm through hole resistor, you could just put it in line with your wire. In this particular case, because I'm using the RGH3 QSB, it is going to go on the little place that says R1 on there, right? So this little section on the QSB on this arm, there we go, and take our 1K ohm resistor, plop her down there. And what I like to do is just go ahead and get some solder buildup on my iron, and then hold this guy in place and just tack her down, and then perform any adjustments. So it doesn't have to be perfectly on there, right? Electrical conductivity does not require beauty. I have rosin core flux here, so or rosin core solder, so my basically my solder has a little bit of flux in the center of it, so that's why it cleans it up, that spot. So we are good to go. RGH3 QSB is installed. We just need to make the little jaunt over to the post connector, and that is really easily accomplished by just using the existing postfix, which we already had, and you would already have if you were doing, you know, a console that had a postfix. And so that is this wire, and the post is going to go to SMC post 1, which is like right next to where the silk screening says R3 R3. So if we zoom in over here, right, this guy is where we need to route that wire. So there's this whole little section here, so we need to spot that and get it wired up. Okay, so here's C3R43. C. I'm looking for two little DB3R3, DB3R3. Okay, it looks like this is the point that I want. So the way I reference that is in the image, I keyed in on these two kind of out of sequence resistors. They're up and, or excuse me, these are probably capacitors up and down, and then these that are side to side, kind of referencing that in the image, and then coming back up here. So the wiring in the image is kind of covering, but it's this DB3R3 is the point that we're going to here. So we actually can trim up our wire quite a bit. And what I like to do is just pre-tin the wire a little bit, which just means soak the exposed bit in some solder, and it'll kind of wick it up. And then, once again, I should follow my own advice. Flux is your friend. So here's some flux. Go ahead and put that on the point here. Alright, I'm just gonna kind of see if I can tin that up a little bit. And I'm gonna use the tweezers for this, but I'm gonna kind of put a bend in the wire there. And then when I grab with the tweezers a little further back, I can use that to kind of leverage and route this thing how I want to route it. So that's what I want to do there. And then now we can just push this little bit back through the hole. And we get a nice tight little corner onto the desired point. Alright, and then so the next wire that we would be doing, back to the video here, is from the little via that we scraped before over to this DB3R4 point, which is real close. Now the cool thing is, since we've already done the RGH QSB, and it has the resistor in line, we don't have to redo that, right? Because electrically speaking, we're going from here through the resistor over to this PLL point. So when we wire this up, we really only have to jump from the PLL point over to, the point where it's at. So I need just a little bit of wire, and I think these might just be long enough to do it, some of the other wire. So let's recycle. This is one of the wires that I took off the Ace. I'll use that PLL point, and then I'm just referencing the image. So remember those two vertical ones that I pointed out, the capacitors here, and then there's that R3, R8, and DB3, R6, all this. So R3, R7 says there, and then printed in the other direction. So it's definitely this point is what we're going after, DB3R4. So go ahead and see if I can tin that guy up a little bit. And then same story, grab my tweezers. See if we can't connect that guy up. Oh, yeah. Not following my own advice. I'm like, why isn't this working very well? Don't have any flux there. So don't be like me and forget to put your flux. Sometimes use the end of the wire. And kind of put the bend in it. Alright. Boop. Come on now. Boop. And there we go. Got a nice little connection with our other wire. So that is it. Again, if you were doing this without the RGH3 QSB, right, your wire would start here, you would go through a 1K ohm resistor, and then you would end up at the other point. And then if you had regular post, you could go straight from here to this point, or you could run a wire like I did directly from the post fix adapter to that point. So you could see the thermal paste on this thing is pretty caked up and gunky. I'm just going to clean a little bit off the edges here because that's not doing anything for anybody. And then I'm going to go ahead and slam this thing back together real quick just to do a boot test, because our expectation is now we've written the RGH3 image, we've got the thing ready to go, and then we did the RGH3 wiring, so it should just boot up and be awesome and nearly insta-boot. So let's see. Putting the X clamp back on, I like to slot them in. You can kind of feel when they hit their little groove on two sides. Slot them in, and they just kind of snap in. Sometimes the last one, I'll have to use the fork again to kind of put it down. So I bend it out, and then when you press on them, they shouldn't move. They should be seated within the rings that are in there. Alright, so let me set this thing back inside the case, and then get it plugged in and powered for boot. Alright, we're going to find out together. We just completed the RGH3 wiring. We've already written the RGH3 compatible NAND to this thing. So presumably we should be able to press this button and boot the console to regular dash real quick like. And look at that, nice light and hot dang, we got a nice logo. So let me kill power and boot it with the eject button, and just show you guys that it will in fact boot Zell as well. So eject button, power on, light, and Zell. So we converted this RGH2 Corona Man, it didn't want to play nice. So we converted this RGH2 Corona to RGH3 by removing the glitch chip, installing the RGH3 wiring after we had written the RGH3 image to it. So we never once had to solder in a 4 gig reader writer back to the console. So yes, a little bit of soldering is required, and some fairly skilled soldering, you know, those little via on the back. However, you can do this without having a NAND programming device if your console is already RGH'd. Thanks for watching.